Okay, so there's this invisible force that every single day is reshaping our world. And not just our world, but every other planet and moon in the solar system. I mean, it's something we can't see at all, but its effects, they're absolutely profound.
So get this, what in the world could possibly connect those wispy, high-altitude clouds you see on Mars with, say, finding tiny traces of gold and platinum deep down in Earth's ocean sediments? It sounds like a total riddle, right? But the answer? Well, it reveals this fundamental process that actually links every single part of our solar system together.
And that answer is cosmic dust. It's that simple, but also totally mind-boggling when you think about the scale. We're talking about a constant, invisible shower of tiny particles just raining down on us from space. And this isn't just, space junk. This is a delivery system that's been running nonstop for billions of years.
And just to give you a sense of the scale we're talking about here, that constant shower adds up to about 43 metric tons. Yeah, you heard that right, 43 tons. That's how much of this stuff is estimated to fall on Earth every single day. Just imagine that, a constant stream of material from the outer solar system arriving right on our doorstep.
Okay, so where is all this dust actually coming from? It's not just random debris floating around. No, its origin story, it starts with some of the most dramatic and amazing objects in our entire solar system. It turns out the family tree of this dust is surprisingly specific. The vast majority of it, we're talking about 80%, it comes from a particular group of comets. Their orbits are basically controlled by Jupiter's massive gravity, which is why they're called Jupiter family comets. The other 20%? Well, that comes from asteroids and other more long-haul comets. And this next part is absolutely crucial. See, not all dust is created equal. The dust that comes from comets, it tends to just slam into our atmosphere at these incredibly high speeds. It's way, way faster than the dust that comes from asteroids, which is a lot slower. And that difference in speed, that is the key to literally everything that happens next. So what happens when one of these tiny, super fast particles finally meets our atmosphere? Well, this is where things get really dramatic. This is the most intense part of its journey, a fiery, transformative plunge. Yeah, it's a process called meteoric ablation, and we can basically break it down into 3 simple steps. First, the particle just smacks into the upper atmosphere at this immense speed. Second, the friction, just from hitting those air molecules, heats it up to thousands of degrees, and it starts to melt. And finally, that intense heat just completely vaporizes the particle, literally atom by atom. But here's the really elegant part. It's not just some chaotic explosion. The whole process is incredibly organized, and that's thanks to something called differential ablation. See, because different elements inside that dust particle vaporize at different temperatures, they get released at different altitudes as it falls. It's like a tiny chemical sorting machine high up in the sky. And this is the result. You get these beautiful, distinct layers of elements literally painted across the upper atmosphere. The more volatile stuff, like sodium, it vaporizes higher up. But the tougher elements, the ones that can take more heat, like iron, they hold on a bit longer and get deposited lower down. The dust particle literally sorts itself by its own chemical signature as it dies. It's incredible. So the original dust particle is gone, right? It's been completely vaporized into individual atoms. But its ghost, its legacy, it lingers in the atmosphere. And that leads to the creation of something called meteoric smoke, and a really surprising connection to clouds on totally different worlds. You see, those individual atoms that are just floating around up there, they don't stay atoms for long. They cool down really fast and then recondense into these incredibly tiny, nano-sized particles. This stuff is what scientists call meteoric smoke. And these little smoke particles, they're basically the seeds for something much, much bigger.
Essentially, these little particles of meteoric smoke act as a nucleus, a seed, for clouds to form around. So here on Earth, way up in the super cold mesosphere, water vapor freezes onto them, and that's how we get our highest clouds. But now check this out. On Mars, it's the exact same process, just with a different ingredient. Carbon dioxide gas freezes onto that same meteoric smoke, and that's what forms those wispy CO2 ice clouds. It's the same cosmic dust, just creating totally alien clouds on another world. Amazing!
Okay, so we've seen what happens up in the atmosphere, but what about the stuff that actually makes it all the way to the ground? Well, this dust leaves behind a chemical fingerprint on the planet's surface, a kind of footprint that just builds and builds over geological time.
Okay, I gotta say, this is one of my favorite insights from this whole thing because it's so counterintuitive. We always think about big, dramatic meteorite impacts, right? But if you look at the data over millions of years, the total mass from that constant, gentle rain of tiny, tiny dust particles actually adds more material to the planet's surface than all the big meteorites put together. It's proof that the small stuff really, really adds up.
So what exactly is in this special delivery? Well, some of the particles, especially the slower ones, they actually survive that fiery plunge without completely vaporizing, and they bring with them this precious cargo. We're talking rare elements like iridium and platinum. That's why we find traces of them in deep-sea sediments. They also carry water trapped right inside their mineral structures. And, maybe most important of all, they deliver complex organic compounds, the literal building blocks of life.
And this isn't some brand new idea. Way back in 1989, a scientist named Edward Anders proposed this exact mechanism. And this quote really captures the profound possibility he was talking about, that the early Earth was basically seeded with the raw materials for life, all thanks to this slow, steady accumulation of cosmic dust. It's a really powerful thought, isn't it?
So when you really get down to it, this isn't just an Earth story, or even a Mars story. This whole process, the creation of dust, its delivery across space, and its transformation, it's universal. It's happening right now, on every single planet, every moon, every asteroid in our solar system. It's constantly linking all of them together in this huge, shared chemical exchange.
And that leaves us with this final, really tantalizing question. When we search for the origins of life, our minds often jump to these big, dramatic events, like giant asteroid impacts or some complex chemical soup on a primordial Earth. But what if the answer is quieter, more patient? What if the essential ingredients for life itself were delivered not with a bang, but in a whisper, carried here on trillions upon trillions of microscopic grains of dust all the way from the distant comets?